Trying to run the tables at a 9-ball competition, you line up a shot on the 3-ball, 160 grams. You strike the ball with the cue, and the cue moves off at 0.64 meters per second, 42 degrees. If the collision is completely elastic, what is the final velocity of the 3-ball? Well, the fact that it's completely elastic tells you that kinetic energy is conserved. So that means the before equals the after for both momentum and kinetic energy. So let's set up the momentum first. So in the x direction, we have P1 plus P2 is equal to P1 after plus P2 after. Well, if we let P2 be the 9-ball before the collision, it shouldn't be moving. So all that we have is the mass times the velocity of the cue ball. After the collision in the x direction, we have the mass of the 9 times its velocity, the mass of the cue ball times its velocity, plus the mass of the 9-ball, I'm going to label it as a B, not a 9, times its velocity. Now we know that the velocity of the cue ball is 64 or 0.64 meters per second at 42 degrees. So the x component is going to be 0.64 cosine of 42 degrees, and the y component is 0.64 sine of 42 degrees. MC times 0.64 cosine of 42 degrees plus the mass of the 9-ball times its velocity in the x direction. In the y direction, we have the same thing. Since the 9-ball wasn't moved before, we have the mass of the cue ball times its velocity, I'll label these as x, in the y direction is equal to the mass of the cue ball and the mass of the 9-ball. Well, we know the mass of the cue ball is not going to change. In this case, we're looking at the y component, 0.64 sine of 42 degrees, plus the mass of the 9-ball times its y component of velocity. Now, kinetic energy is conserved as well. But here it's a speed issue, not a velocity. So since the 9-ball is not moving, it's 1/2 mv squared for the cue Now we can think of the Vc squared as Vx squared plus Vy squared to the 1/2. Now we know, in fact, the speed of the cue ball. That was 0.64, so we can square that. And we can do the same thing that we did for the initial mass or initial velocity of the cue ball for the 9-ball after the collision. 2a squared. Now at this point, what we have, MC is a constant. We know what that is. But now we have a series of equations, not all linear, that we would have to solve. At this point, it gets just a matter of an algebra exercise. Consider this problem. I'm going to let you consider this one and think about what's going on.